get started with logarithmic differentiation. This is one of the important type of differentiation because most of your competitive exams ask questions based on this type of differentiation. Okay? Of course, the other type of differentiation also is asked, but high probability that from this particular type it will be asked. So let us discuss about this. And first thing that you have to know is about logarithmics and what is logarithmics. Right? You might have studied about exponents. Yeah. So what are exponents and when do we use exponent? If I have any number and if I have to multiply that number again and again, right? For example, 2 multiplied by 2 or 2 multiplied by 2 multiplied by 2 or 6 multiplied by 6, 6 multiplied by 6 multiplied by 6. If a number is repeatedly multiplied with the same number, we use exponents. Right? For example, 6 raised to the power of 3 would be that 6 is multiplied with itself 3 times. If it is 10 multiplied 10 raised to the power of 4, it is 10 raised to the power of 10 multiplied by 10 multiplied by 10 multiplied by 10. Right? As simple as this. And you know about exponents and you have learned about it. For example, 6 squared is 36 and 10 squared is 100 and 3 raised to the power of 3, 3 cubed is 27. This you already know. Right? Now, if you know this, logarithmic is going to be very easy because they just are kind of reciprocals of each other. Right? What do I mean by that is, in mathematics, logarithmic is defined as the other way of writing the exponent. So this is one way how you represent the exponent. And what is the number 6 called over here? The number which is multiplied with itself would be called a base. Yeah? And number on the top, that would be called the power. What would power represent? Power would be representing how many times, or it would tell you how many times the number is multiplied. For example, 6 raised to the power of 2, this means that 6 is multiplied with itself 2 times. 6 multiplied by 6 is 56. Similarly, 3 raised to the power of 3 means that 3 is multiplied with itself 3 times and the answer is 27. Yeah, this is what base and power will do. So base will tell you which number has to be multiplied and the power will tell you how many times the base has to be multiplied. Yeah, getting it? Now, the logarithmic is of a number. Logarithmic of a number. Here, exponent of a particular number will tell you how many times the number has to be multiplied. Similarly, logarithmic of a number with a base, it will be having a base as well, that is going to be equal to another number. And I will show you how this works. Okay. For example, and we have a formula for this one as well. If I have b raised to the power of x, which is equal to a, right? This can be written down as x is equal to log of a to the base b. Log of a to the base b. So over here, what is this? 6 raised to the power of 2 is going to be 36, right? So what does this tell you? This tells you that 6 has to be multiplied by itself 2 times, isn't it? Now, let us come to over here. Log 36 to the base 6. This should be read as log 36 to the base 6. This should be read as log 100 to the base 10. This should be read as log 27 raised to the base 3. Now, here what it means, I will repeat it again. 6 raised to the power of 2 means that 6 is multiplied with itself 2 times. 10 raised to the power of 2, 10 is multiplied with itself 2 times. 3 raised to the power of 2, 3 is multiplied with itself 3 times. This is what it means. Yeah. Now, coming to logarithmics, whenever I have logarithmics, you have to remember one thing. And what are we finding out over here is that how many times you have to multiply the base in order to get this particular number. 6 has to be multiplied with itself how many times in order to get 36? 2 times, right? So over here, log 36 to the base 6 is 1. Similarly, log 100 to the base 10. So base is 10, 10 should be multiplied with itself how many times in order to get 100? It is 2 times. Similarly, here we have log 27 to the base 3. What does this mean? This means that how many times 3 has to be multiplied with itself in order to get 27? 3 multiplied by 3 multiplied by 3 is 27. So I have to multiply 3 by itself 3 times in order to get 27. Is it clear? What is logarithm now? This is the formula. If I have b raised to the power of x is equal to a, the same thing. Here it was 6 raised to the power of 2. So what is x is equal to? X is the power over here. What was x? Here it is 2. So 2 should be equal to log of that particular number. What is that number over here? Whatever you are getting, that is your number. And base, what is the base? Base is the number that is multiplied. So base is 6 over here. What does this mean? This means that 6 is multiplied with itself 2 times. What does this mean? This means that we have to find out how many times 6 has to be multiplied with itself in order to get 36 or whatever the number is. Yeah. So this is about logarithms. Easy. And here you already know about base and exponent. If I have b raised to the power of x, b is going to be your base and x is going to be the exponent. And whatever the number that you get over here, it is 36, here it is 100, here it is 27, that would be known as argument. Is it clear? So there are three things that you have to know in logarithms. One is argument, one is your base, and one is the exponent. So how will you understand this one? This means that how many times the base has to be multiplied in order to get the argument, that is the value of the exponent. I will repeat it again. Logarithmics will tell you how many times you have to multiply the base in order to get the argument. And that value is going to be equal to the exponent. And that can be written down as base raised to the power of x. Okay? Now, we will be using this in differentiation as well. So before this, you have to know few formulas related to logarithmics, and these are the few formulas. If I have log of 1, then it is directly going to be equal to 0 regardless of the base. Okay? Next, if I have log of any number and base is also the same, then it is going to be 1. Of course, right? Because why? Any number raised to the power of 1 is the same number. Same logic over here. Just like we have laws of exponents, a raised to the power of m multiplied by a raised to the power of n, a raised to the power of m divided by, we have that, right? Similarly, we have logarithmic rules or logarithmic properties as well. Now, if I have log of any two numbers which are multiplied with each other or two terms which are multiplied with each other, I can write this as log of x plus log of b. The product can be written down as sum. Similarly, if I have division, then I can express that as the difference of those two terms. That is the value of x, the numerator, and y. Right? So most probably we'll be using this, and we'll be using the power rule as well. Most of the times we'll be using the power rule. Most of the times. So if I have a raised to the power of x, log of a raised to the power of x to b can be written down, or to the base b can be written down as x, you can bring it over here, and log of a raised to the power of. So most of the times we will be using this one. That is your power rule, and let me tell you how we can use this in differentiation. Now, the first question. If y is equal to x raised to the power of x, find dy by dx. This is the first question. So what I will do is, first I will start by taking log on both sides. So left hand side I have y, the right hand side I have x raised to the power of x. So I will take log on either sides. Here I'll be getting log of y, here I'll be getting log of x raised to the power of x. This is the first. Okay? Got it? And now, when do we use logarithm differentiation? That you have to know, right? We will be using logarithmic differentiation, or you should be getting an idea to use logarithmic differentiation when the power is not a real number. If I have something like x raised to the power of 2, then you can use your power rule, right? X squared is 2x. Similarly, if I have x raised to the power of something else, for example 4, again I can use power rule, right? Plus something, again I can use power rule. But if I have something like x raised to the power of x, x raised to the power of sin x, cos x, e raised to the power of something like that, in that case I can use logarithmic differentiation. This is your key. Now, I've started by taking log on both sides. So left hand side I have got log of y, on the right hand side I have log of the same exponent, which is x raised to the power of x. So from the power rule, what do I know? I know that if I have a raised to the power of any exponent, that is a raised to the power of x, I can write this as x multiplied by log of a. Here I have, instead of a raised to the power of x, here I have x raised to the power of x. So what will happen? This x can be multiplied, this x can be brought over here, and log x is going to be remaining as it is. Is it clear? This is which rule? This is your power rule of log. Power rule of log, not of differentiation. Differentiation is different. Power rule of log. I will repeat it again. Log of any particular exponent if I have, you can multiply the power over here and you can write down whatever is left out as it is. So here I have log of x raised to the power of x. I can write this as x multiplied by log x. If I have log of x squared, I can write this as 2 log x and so on. Yeah, most of the times I will be using this particular rule. Now, I will differentiate on this. So log of y, I know that log x differentiation is 1 divided by x. Log y would be 1 over y multiplied by dy by dx. And on the right hand side now, it is x multiplied by log x. I will be using the power rule. X as it is differentiation of log x, it is 1 divided by x plus log x as it is the second term plus multiplied by the differential of first term, it is going to be equal to 1. Now you add both of them. Before that, you can simplify x and x can be simplified with each other, right? And y is there, so y can be multiplied with each other on the left hand side and the right hand side. So the left hand side it will be getting cancelled out, and you will be left out with dy by dx, and you can just multiply y with 1 and y with log x. This is going to be the value of dy by dx. This is your final answer. You can keep it. Similarly, I will go to the next question as well. So here it is y raised to the power of, so x raised to the power of cos inverse x. Again, just by looking at it, you know that the power is not a real number. It is a trigonometric function. So the Q is using logarithmic differentiation. You start by taking log on both the sides. Left hand side I have y, so I will be getting log y. On the right hand side I have x raised to the power of cos inverse x. So you take down x raised to the power of cos inverse x. Here I had x raised to the power of x, so it was x multiplied by log x. So here what it should be? It should be cos inverse x multiplied by log x, as simple as that. So whatever is the power is there, you take down over here log x as it is. Now the next thing is differentiation. Now you can differentiate on both the sides with respect to x. Differentiation of log y is going to be 1 divided by y multiplied by dy by dx. And here again you can use the product rule. You can keep cos inverse of x as it is. The differential of log x is 1 divided by x. And you keep the log x as it is. Differential of cos inverse of x is negative 1 divided by square root of 1 minus x squared. Now you have to transfer y onto the right hand side in order to get dy by dx. Right? When I do that, I should be getting y multiplied by cos inverse of x divided by x log, and here the negative sign is multiplied, so it is going to be negative log x divided by square root of 1 minus x. So this is how you solve. Similar question. Yeah, the method is going to be remaining the same. Let me discuss a couple more problems and then I will be giving you the question to solve. Again, so y is equal to sine raised to the power of tan x. Start by taking log on both the sides. Log y is going to be equal to log of sine to the power of tan. Tan can be multiplied, so directly I have taken tan multiplied by log x. Now differentiate on either side. Log differentiation is going to be 1 divided by y multiplied by dy by dx. And here you will be first taking tan and differentiating log of sin x. Log x is 1 divided by x, which means log of sin x is going to be 1 divided by sin x multiplied by the differential of sin, which is cos. Next, you will keep log of sin x, the second function as it is, multiplied by the differential of tan, which is secant square x. Next, you can simplify. How can you write tan as? Tan can be written down as sin divided by cos. And here 1 divided by sin as it is, cos as it is. Now cos and cos would be getting cancelled out. 1 and sin would be getting cancelled out on over here. Yeah, and y is transferred as well. Now you are getting the value of dy by dx. Y as it is, it's multiplied with, this is going to be getting cancelled out, and I have 1. Secant square as it is, log of sin x as it is as well. Similarly, one more question. Y is equal to x raised to the power of 3 raised to the power of x square plus 5x. Again, this is not a real number. It is a variable. Right? It's a variable and it's a quadratic equation. Yes, x square plus 5x is a quadratic equation. Now again, you can use the same logic. Take log on both the sides. Log of y is going to be equal to the exponent multiplied by log of that particular number. So x square plus 5x multiplied by log of 3. Now, you will be differentiating on either sides. Differential of log y, again the same thing you will be getting for all the questions, 1 divided by y multiplied by dy by dx. And here we have the product rule. The product rule is going to be differential of the first term multiplied by log 3. So it is 2x plus 5 multiplied by log 3, and next you will be differentiating log 3. Log 3 is a constant. So if you differentiate or not, it is 0. Right? I have not taken it at all. Now we transfer y to the other side. So dy by dx is going to be a
log will not differentiate, sir.
You will differentiate. You should differentiate, but I have not differentiated because when you differentiate log 3 and you keep x square plus 5x as it is, differential of log 3 is what?
Zero.
0. Log x is 1 by x.
One.
Yes, but log 3 is a constant, right? Differential of a constant is
Zero.
0. So that is the reason why I have not written it down at all. Actually, you should be writing down plus x square plus 5x multiplied by differential of log 3 is 0. So I have not written down the same thing. Next, you can transfer y to the other side. So it is going to be y multiplied by 2x plus y multiplied by log 3. Now, what is the value of y? You already know the value of y. You plug in the value and you should be getting the answer. The y value is already given. It is 3 raised to the power of x square plus 5x, and you can write it over here and you can multiply.
Is it necessary to write?
If some in some cases it will be necessary because the option will not match in that case, right? So only in that case, that is the reason why. If it is needed, only in that case you write down. Here you need not write it. Okay, you can keep it as it is, or you can substitute as well. You can do it. It depends upon your question. If it is just the normal question and you do it, till here you do it, because y should not be there, right? Y is a dependent function. It should be in terms of only dependent functions, not independent functions. Okay, so it has to be only in x. The y value should not be there. I will take one more question, the last one. Right here, I think I have taken square root of x plus square root of x infinity until infinity. This is a similar question as well. Right here, y is given as x raised to the power of x, raised to the power of x, raised to the power of x until infinity. We have to find out the value of dy by dx. Start by taking x is equal to y is equal to x raised to the power of y. Now you take log on by both the sides. When you take log on both sides, you will be getting log y is equal to y multiplied by log of x. Yeah. Now differential of log y is going to be 1 over y, 1 over y multiplied by dy by dx, and here it is going to be y as it is, and differential of log x is 1 divided by x. Log x as it is, differential of y is dy by dx. It is 1, and we should be multiplying dy by dx. Next, you transfer dy by dx to the other side, right? And here I have y square divided by x. Let me keep it as it is. Now, when I bring it over here and take dy by dx as common here, this is going to be 1. So 1 as it is. Here we have y log x. Y log x will be transferred to the left hand side. It will become negative y log x. And on the right hand side, I had y square divided by x. Here also I have y square divided by x. Now you transfer this one minus y log x over here. As in you divide both sides by 1 minus y log x, and we should be having the value of dy by dx, and it is going to be y square as it is, and here x will be multiplied with 1 multiplied by y multiplied by log x. This is going to be your. Is it clear? Alright. Now I will give you a question, and now you can make a note. Okay. This one will stop.